Okay, I think, yep, looks good. We are good to go. All right, hello everyone. Welcome back to our HTTP routing couple of videos. This will be the second one. I might end up just making a separate playlist out of this just because this may become a whole web server on its own. It probably will. But for now, we'll just keep it in here and we'll see where things go. But today we're going to be continuing what we did last time. So if you guys remember, what we did last time was we created a bit of a route tree that we could use to actually, we could use to parse routes and then allow, here, let me actually, okay, yeah. To parse routes and then efficiently locate requests made to a server and using a tree structure here. And we did route arguments, and it was a little clunky with a lot of templates, but it still worked out well. Let me just, okay, I hope the music isn't too loud. But we created this little tree structure, and then we tested it out with a couple of routes here. So I'll just go ahead and run this again. So Control F5. And we got a couple of things. So it parsed everything properly. And we also created a couple of parsers that will allow us to actually look through a string and say, all right, I want an integer out of here. I want a GUID out of here. I want a Boolean, whatever we think. So yeah, today we're going to be starting, or in this video, we're going to be expanding a lot of the functionality here to include HTTP methods, so stuff like get, post, patch, update, or not update, put, stuff like that. And we will also look at query parameters, and that will allow us to make these function definitions much more flexible than they already are. And we will also clean this up a tad, but it's going to stay mostly the same. But we're going to get rid of the template lambdas, which is going to be very fun. And then finally, we will look at body content. So if you pass in a request body, and we will see how that works out. So let's go ahead and get started. I'm going to go to OneNote, and we're just going to look at how we want to go about processing HTTP methods. So far we had a tree that was full of endpoints, and each endpoint was associated with some sort of action. It could have been associated with an action, maybe a page, maybe something else, and each endpoint was determined based on its path and its components that got up to the endpoint. So there were arguments in there, just plain routes. And we're going to extend this definition to just pretty much include methods, because we can have multiple methods for the same endpoint. Like, for example, if we wanted to, so if we have user int, and we could have a couple of things here. So we can either have a get action, so a get action which will return the page with the user. And we can also have, let's say, a put action which updates the user's data. But the point is, we want to keep this endpoint the same. We don't want to have different endpoints saying user int get, user int put, when we can already just specify that with the method. So it's going to require another mapping, but this will be within the route tree node itself. It's just going to map HTTP methods to corresponding actions. So it's not going to be too big of a jump from what we already have, because all the functionality exists. So we just need to use it effectively. So we will start in route tree, and I will find my code, and we're going to go to the route tree node class. And as of now, we have just one thing here called this action, but we're now going to extend this to be a dictionary. So it's going to be public, and it's going to be iDictionary, mapping an HTTP method, which we need to import. So it's going to be, if I remember this properly, using system.net.http, and this should give us access to the corresponding class. And so that's HTTP here. And then we have a dictionary mapping HTTP methods. Oops, sorry. To actions. And these actions, once again, take in an object array. And we will just call this actions. And it's a get and a set. Actually, this should be this will be a private dictionary. We don't want to actually set that, or we don't want to give this public access. So now we don't have this action in there. And we're going to change around our constructors a little bit. We're actually going to get rid of the setting up a plain route with an action. And then we will also be getting rid of the action parameter in both constructors. So we don't want to ever pass in an action to the constructor. So we just have the two constructors now, plain route, with or without an action, and then an argument route, once again with or without an action. And much like we did with the other dictionaries, we're going to create some overriding getters and setters so that we can actually access these. So we're going to have so for the setter, we're going to do an overrider just like this, which overrides the indexer. And instead of, and we will say this, and it will take in an HTTP method key. And then we will have a setter. So set if, and we're just going to make sure that the dictionary exists. So if its actions is equal to null, then we want to initialize it. Actions equals a new dictionary. Sorry, hold on. I'm getting some buffer. Oh, shoot. All right, it's poor, but I hope this is still going through a little bit. So actions is equal to a new dictionary, and it's just going to be the type. I will actually start recording just in case it doesn't go through properly. So new dictionary, mapping HTTP methods to an action with an object array, like so, and then we simply just say actions at key is equal to value. So value is the argument we're passing into the set method here, and the key is this one right here. And then we will also have a try get method, much like we do with the other ones. So it's going to be, okay, connection is back. That is good, good, good. I hope it didn't cause too much ruckus. So we will say public bool try get action, passing in an HTTP method, and then we will output an action action. And here we'll say action is equal to default before we access the dictionary, because we will just say return actions dot try get value, or sorry, return actions dot try get value, and we'll pass in the method as a key, and then we will output a value, or output the action, and this just accesses the dictionary. And I suppose, I never really thought about it like this, but this may be, this will throw an error if it doesn't exist, or if the dictionary doesn't exist. So we're actually going to do the try get like we did with the subroutes. So instead of just a two-liner, we're going to have to expand it just a little bit for extra checks. So if, then we have to have an open set of parentheses, actions, question mark, so this is the null operator, dot contains key, and we'll pass in method as the key, close parentheses, dot get value or default, and then we will say action is equal to actions at method and return true. Otherwise, action is equal to default and return false. Just like so. So this just makes sure that the dictionary actually exists. And I suppose we could make a static function out of this, but that's not the point of this right now. We can make a static template function because we do this 3 times, so it could just make it a little easier. Okay, so we now are set up with actions in the route tree nodes. And we have a way to access them too. The only thing now is that when we say add route, we need to pass in an HTTP method. So I'm now in the route tree class. So in the add route method, we're going to have an extra parameter called an HTTP method. And then when we set the action, so once we find the current node that we're targeting, so after the loop, we're going to say current node at method is equal to action. So we're just mapping the method to the action. And then we're going to have a bunch of errors with the template methods, but we'll get to that in a second. And then in try navigate, instead of just saying this action, we're going to do a couple of things here. Instead of the try catch block, we're going to do if current node dot try get action. We're going to use the new method, and we're passing in the method and out variable action. Then we're going to invoke the action. So action, in try navigate, we also need to pass in an HTTP method, because we need to determine, all right, what method are we using so we can access the mapping properly. And then we invoke with the route args list dot to array, and then we return true. Otherwise, we're returning false. Okay. All right, so this will allow us to actually modify, or not modify, but get the corresponding action to the method that we pass in. God, it's getting another error. That's a shame. I'm recording, so if things do screw up, I will just upload the recording afterwards. So for template add methods, we have a bunch of errors now because we're not passing in the new method key. So we need to update the way that we generate these methods so that it can take in an HTTP method. So something like this. So I'm going to update the one with no arguments because we don't generate that using the script. But this method will just be passed into add route. Just like so. Okay. And then in program.cs, where we actually generate this, I'm going to first comment out all of the stuff for the route tree here, and also all of the argument type stuff because we don't need that anymore. Oops. And then I'm going to uncomment the script. And what we're going to say is we just need to add the new method. So we say public void add route, and the template parameters are going to stay the same. So this all right here stays the same. In the parameter list, so before string route, we just need to specify HTTP method. And then when we call add route, we need to pass that method in. So this should be the new string. This should be the new function signature that we're going to be creating. And I'll go ahead and control F5 to run. Build errors. Uh-oh. What happened? Ah, yes. I needed to get rid of the existing add route methods because they are all wrong. Okay. All right, so you run this and it gives you this massive list. And I'm just going to copy it all and paste it. like so. And we now have all of our template methods set up again. So I'm going to go back into program.cs and I'm going to comment out the script. And I'm going to uncomment the route tree node, and we're going to actually test this out now. So we have rt.addRoute, and we need to pass in a method now. So we need to include the HTTP method class, and a cool way to do that is just using static system.net.http.http method. And this will allow us just to call HTTP get without having to use the prefix or the class. So when we say add route, we can just say get. And then for add route hello, we can say post. And then put for int. And then another one is patch. Oh wow, didn't know that existed. I thought I had changed that, but there we go. So patch. And then when we call try navigate, we need to call them with their corresponding methods. So it'll be get. Hello is post. And then we will say put for the integer. And then for the string one, it doesn't matter, it's going to give us an error. But what if we try doing hello on patch? And then 15.5 will also give us an error. So let's do 15 with delete. And then hello test 17 ASDG will just do patch. So that will succeed. So we should get a couple errors or a couple of false results again. I think they should be these two. So we should get 4 successes and 3 and 2 errors. So if we run this, we have true, 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 false, false, and true. So it all works out. No differences in the way we're handling methods, no differences in templates. Well, I suppose a little different, but not in the templates themselves. No differences in these actions up here. It's just we're passing in an extra identifier with the route. And again, we're just doing that by attaching another dictionary to the route tree node. All right, so that is HTTP methods. Now we're going to be doing query parameters. All right. And this will be a fun thing. So what are query parameters? So I will take out my tablet again. Need to find my pen, which there it is. So I'm going to go back here. And let's look at a sample route again. So let's say hello. And a query parameter is just going to be something that you tag on the end. So it might not be a string argument. It might not be in the route. You can also pass stuff after a question mark, and they can have tag identifiers. So we can say hello name is equal to Michael. And we can also do /15 increment is equal to 7. And we'll try doing that one actually, because that'll be something that we can visibly see. So we have this, and you can also have multiple ones, and you just have to separate them with an ampersand. So we can say hello name is equal to Michael, and we'll say place of birth, or I don't know, home. Where is my home? Let's say, ooh, this is a good question. I've never thought about this. Let's say Antarctica. I actually live there. That's where I am right now. I'm in Antarctica. But so yeah, query parameters, you can do whatever you want with them, and then we'll have some cases because there's this thing called an escape string where if you say want to have a space in, so if I wanted to put my full name, I wouldn't put a space here. I would put a Michael %20 Greco. And the %20 is just a hex encoding for 2 times 16 plus 0 times 1, which is 32, which is the character value of a space character. So we will have to deal with that encoding as well. So let's head back into, or actually we'll stay here for a second because we need to go over a couple more things, because the parsing it won't be hard. I can actually, let's do the parsing right now, and then we'll head back to the drawing board and look at more requirements. So in route tree, we're going to go into navigate, try navigate, and this route may have those query parameters with it. So what we want to do is we want to pass in or create a new dictionary. So iDictionary, mapping a string to a string, query parameters is equal to a new dictionary mapping a string to a string, just like so. And we're going to find the place where the parameters start. So integer parameter index is equal to route.index of, and we're trying to look for that question mark again. And another thing with the encodings is that it's not only spaces that they encode, it's also equal signs. So if you have an equal sign in your parameter, it will encode that as % whatever it is. But just so we don't screw up any of the encodings here. So we're looking for a question mark, and then we're going to say if parameter idx does not equal -1, and then we're going to say string parameter array is equal to route.substring. So we're going to get everything afterwards. So parameter.index +1, so that's the string afterwards, and then we want to split it by the ampersands. So .split around the ampersands, because we want to get each entry individually. And then we're going to update the route so it doesn't include the parameters. So we just need to chop it off by saying route is equal to route.substring 0 to parameter index as the length. And route still points to the whole route. We've just taken a part of it for the parameter array, and then now we're chopping off the end of it. All right, and then we're going to say for each string parameter string in parameter array, we're going to get the key and the value, and they're split by an equal sign. So we're just going to do string array split param is equal to parameter string dot split around an equal sign, and we're only going to get 2 values, and I don't care if it doesn't happen. I'm relying on not throwing an I'm relying on the URL having a proper format. I'm not going to do any checking, although we could. It's entirely possible. So we're just going to assign to the parameter array. So query parameters, and the first element of the array will be the key, but we're going to escape it. I'm not sure if you can actually have spaces in your keys, but we're just going to assume you can. And the way to get the escape data is, or the unescaped data is URI.unescaped data string, and we're going to pass in split param at 0. And then equals, we're going to do the unescape again. So URI.unescaped data string split param at 1. So the key is over here and the value is over here. And we can go ahead and test this out, but I'm just going to tell you it works, and we will test it out in a second. But we have the parameters now, and we could just add them to the route arguments list. Why not? We could we could do that. However, it's not as easy as that. We haven't parsed any of the data just yet, not yet. But it's not as easy as just adding a bunch of strings to it. Not just because we haven't parsed it, but because the order of the parameters doesn't matter. I could say hello and have the first parameter be home, like that. And it would get the home argument first. And it's also not guaranteed that the dictionary stores it as we pass it in. So we're going to have to do something with named arguments. So where we actually link the titles of the keys of the parameters to the names of the arguments. So let's say we have a static void action hello query taking an integer or a string name, and we'll say an integer age, we'll say. And I'm going to do console.writeLine passing in hello with age, like so. And I want to be able to say, all right, I want the name there and the age there. But what if they pass in the age first? Well, we wouldn't get it in that order. So it would then be trying to pass an integer to a name and a string to an age, and it wouldn't work. So what we're going to have to do is modify the way that we actually pass in our actions. And this is where delegates are going to come in. So far we have an action that's stored at each route tree node, and that action takes in an object array, and that object array is what we populate and parse. And everything's passed in order. Now this is cool and all, but this may not work as well as we want. Especially just because of all the reasons I said. So we're going to use something called a delegate. And a delegate is just a generalized action. It's a system.delegate, and it's what all the action classes inherit. Or not inherit, but they are linked, or that you can use them as delegates. It's just they don't have any constraints on the parameter types, and you can't call them directly. So I can't, if I have a delegate object, I can't call that directly. A system.delegate object, I can't call that directly. With actions, you know exactly what you're passing in, but with delegates, you're not necessarily sure. You have to use delegate.invoke, but you can't just call the delegate directly as a method group. So we now have delegates here as the action, and we're going to have to change a couple of things. So I'm going to first rename this to functions. And this is going to give us a bunch of stuff. So we need to change our overriders. So if functions is equal to null, then functions is equal to a new dictionary. Oh, that's not right at all. If functions is equal to null, then functions is equal to a new dictionary. And we'll say delegate. So HTTP method to delegate. And then we need to also change the type up here to delegate. And functions at key is equal to value. So that's the setter. And then the getter will this time output a delegate named function. But it still takes in a method as a key. And we're just going to rename actions to functions. And then we will assign like so. And then we return false otherwise. But everything should work mostly right now. We have a couple of compile errors, especially with the try get action. But you would see that the plain routes, or the setting this, is still the same because the action is, like I said, it is a delegate. So the only difference is now in current node.tryGetAction, we need to call, or this needs to be tryGetFunction. I need to rename that. Sorry, this should be tryGetFunction. We need to say current node.tryGetFunction, out variable function. And instead of calling function with the route args list as an array, we're going to call function.invoke, or dynamic invoke, sorry. And here you can see that the dynamic invoke may not return an element, and it may not need arguments, but we're going to pass in route args list dot to array, and it may return something we don't know. But you can see how this is a little different from the other stuff, from just calling the action. But this is still to array. And we can go and build this actually and run this, and we still should get the same results because nothing has changed otherwise. Parameter count mismatch. That sounds about right. It's not finding as many arguments as we need to invoke the function. And that actually is correct, because if I actually just said route args list here and built it and ran it, it would still give us stuff. But the point is, I'm passing this in as a parameter array, so it's going to take every element individually. But dynamic invoke is trying to call an action that takes in an object array, not a parameters list. So it's looking for one object array, but it's getting multiple objects that were in an array, but it doesn't like that. So we need to change our add route functions. And it's going to become much, much simpler. So instead of having add route, it's still going to be called add route, and we're going to pass an HTTP method, a string route. But this time, no, this all stays the same, I believe. Oh, no, actually, sorry, my mistake. We need to get rid of this lambda call, because that's what's screwing with us. Because in the lambda call, this is where we want to take in an object array and then split it apart. But we are okay now with taking in multiple objects. So we need to pass in add route into add route, the method, the route. But this time, instead of passing in the lambda, we just pass in the action. Just like that. Does that work? Oh, yes. And then in the actual private add route function, instead of passing in an action, we're passing in a delegate now. And we'll call it a function. And you see now we have, here come the compile errors, except for the first one. So instead of having a lambda, we are just going to call the function without a lambda. And that will speed up our execution quite a bit. So let's go and update our script. So we'll go back into program. I'm going to comment out all the route tree stuff. Uncomment the generation script. And so we have add route here, does all this. And let me just see what it's supposed to look like. So we still have the add route, and that's all the same. And we now have an HTTP method, a route, same. And then the action will stay the same because we're still just going to, it's easy to, it's easy to convert a method group to an action, but you can't do it to a delegate. So we're going to keep the action template here, and we'll rename it to function. However, we're going to delete this last bit, the last thing here that we're passing into the add route private function. So we're deleting the lambda, and when we call add route in the string, it should be method route and then just function, just like so. So the only difference between all of our functions now is we're not doing any casts. We're just varying the templates that we pass it. Nothing else. There's no lambdas, there's no storing lambdas, there's no capturing variables, there's none of that. And this is going to be a much more efficient way to do this. So we'll go ahead and run this. Build errors. Yes, I need to once again delete all of the template methods because we're going to rewrite them. So So FN or Control F5, and you see I'm gonna have 16 methods again. That's not gonna change. But they are only one line and there's no lambdas involved. So we've taken an add route with 16 template parameters, and the action also has how many of our parameters. But this time we're passing it into the private add route function is the method, the route, and the function itself, no lambda bullshit. Okay. And I'm going to do a build, all good, and I'm going to run the program with the route tree node stuff again. So this is, we're no longer looking at query parameters just yet. We've put that aside for just so we can get named arguments moving. But build again, Control F5, and everything works just the same. And you see it flashed instantly. With the lambdas, it kind of rolled out. You could see each line get output, but this still works wonderfully. So there's nothing wrong there. However, we're still not at named arguments because we still rely on the order of the route arguments. So I'm going to go to route tree.navigate, collapse this. So we have try get function there. Sorry, let me look at my reference. Okay. So we're going to comment the try get function out. Actually, we're not going to comment it out. We are going to replace the dynamic invoke with something. So delete that dynamic invoke. So right now it should just be if we found a function, then we return true. Otherwise, we're returning false. And this is where we're going to construct our argument list. And we're going to construct it as a list of objects. So iList of object args list is equal to new list of objects. And then at the end goal is going to be function.dynamicInvoke passing an args list .toArray. So the only difference now is we need to construct this list so that its entries correspond to the arguments of whatever delegate we have here. So with action hello query, we want name and then age, no matter how we passed it in. With hello test int string, we want number and then string, no matter how we passed it in. So we're going to construct this now. And lucky for us, delegates have so much information. And I had a blast writing this code because I didn't know that all this stuff existed. I was like vaguely aware, but getting to actually program with it has been a lot of fun. All right, we will start by iterating through all the parameters of the function. And that sounds funny, but you'll see what I mean. For each variable param in function.method.getParameters. And that's awesome. We can actually treat the function as an object and then just get its parameters. And each of these parameters, you can just go through IntelliSense. Parameter.parameter type, name, is out, position, attributes, default value, custom attributes, blah, 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 blah. It's so cool. Okay. So we're going to say, we're first going to try and get our parameters from the argument list, or from the actual URL, the path. So we're going to say if route arguments, oh, yes. My mistake, I forgot something first. We haven't named our route arguments yet. We just have them in a list right here. So what we want to do is change this to a route args dictionary. So route args, and make this a new dictionary mapping a string, the name, to an object. And then we will have iDictionary, mapping a string to an object. And you guys are gonna get mad at me, but we have to redo a couple things. So all we have to say here now is route args at some key is equal to value. Now we have to determine this key. And we haven't stored that yet, but it integrates perfectly with the node. So we have at each route tree node, we already have an arg type, which corresponds to the argument. So why not just tag on a name there? So public string arg name get and set. And then for the key now, we're going to say current node dot arg name. Just like so. So we have current node here. Oh wait, actually, oh no, this works. I'm sorry, this works. So yeah, current node is the next node that we're navigating to, and it has an argument type and an argument name, and we don't. So yeah, that's the argument name there, and this type corresponds to whatever node we're navigating to. But we looked at that last time. So now we need to set up this argument name. And the easiest way to do that is just in our routes, we can just pass in a name before the type. So we'll say integer. So we need to correspond it to our actions here. So number. So we'll say number colon integer. And then for hello test, it'll be number colon integer. And then string colon string. So it's name colon type. And we can also have a default as string, so we don't need to specify that there. Now to parse this actually, because we can't parse this as that, we need to go back into route tree. And when we have add route, we need to do something else. So we have the type string, which gets the value in between the curly braces. And we're now going to get the name. So we need to find the index of the colon. So int idx is equal to type string dot index of colon. And then if idx is equal to -1, then we want to get the type and if the index is -1, then we didn't find it. So we're going to assume the type is a string. So we are going to set the name to the actual type string. Sorry, we actually haven't defined name yet. I'm going to say string name is equal to string.empty. So name is equal to type string. And then now we're going to update type string to just be a string. So it points to, or it corresponds to the type of a string, so that when we say argtype.getArgtype, with that, it gets the string argument. And then otherwise, we have a name and a type. So we're going to say name is equal to type string dot substring from 0 to the index. And then type string, we're now going to update so that it's after the colon. So type string dot substring from idx +1 all the way to the end. So we're going to split it up at the colon. And in route tree node, we now want to pass this name in to the constructor. And we now need to update the constructor here. So string arg name, and this will simply just set the value. All right, I bounced around a lot in the code, so I'm going to go over from top to bottom what we changed. So in route tree node, we now want to associate a name with our arguments. So that's what this new property is for. We're going to add that property to the constructor so that you can actually set that when we set the argument route. So with the argument type, we're also setting the argument name. Now, I'm going to go further down into the route tree class. In add route, whenever we find an element that corresponds to an argument, we want to get the string, which contains the name colon the type. So we need to split it at the colon here. And if we didn't find it, then we're just assuming it's a string. So we just take the whole name, or take the whole string as the name. And then otherwise we're taking in, and then we're going to set the type string as a string, so the type gets mapped properly. And then otherwise, we are going to take the first part as the name, which is this, and then the second part is a type string. And then we pass it into the new route tree node constructor. Okay. Now, and then in program, when we actually set up our routes, we need to pass in this name of the argument as well, which directly corresponds to this. Right? So we're going to use these names now. So in route tree, I'm going to go down to navigate, and we're saying we were at for each parameter. And now I'm going to say, oh, actually, sorry. And then in route R, when we're getting the argument from the route, we use the current node's argument name as the value. And then when we iterate through all of our parameters, we're going to try and get the parameter corresponding to that name. So if route args dot try get value, and the key is going to be param dot name, and then we're going to say out object value, and then here we're going to say we found it from the route, so args list dot add value, and then continue. And the reason why we're going to continue is because if we haven't found it, we still need to have a parameter corresponding here, just so the count lines up. So if we haven't found anything, we're going to say args list dot add null, just so that it's a placeholder variable. So we can actually try this, and I'm going to build, and we'll try again running. And it still works. I'm not pulling any voodoo magic, don't worry. There's no voodoo magic at all. We're just mapping a number or arguments to their types and their names now. We already did it. We already mapped a node to a type, an argument node to a type. Now we're just adding a string. That's all it is. And we're using that string to identify what parameter we want to set. I'm going to do a quick demonstration before we look at query parameters. But when so let's say we have our endpoint, which has an integer ID, integer device ID, and a string new name. And let's say this corresponds to client /ID as an integer /device /device ID as an integer, and then a query parameter new name is equal to whatever. Just like so. All right. So this ID corresponds here. This device ID corresponds here. And then this new name corresponds here. So when we get a request like client, and this is obviously just simplifying the route, the method. We're not considering that right now. But let's say this was a put one. So let's say we have put client 64 /device /5, and we're going to say the new name is equal to computer. So we're going to go through this route, and we're going to take it apart piece by piece as we usually do. So I'm going to just list the elements. So we have the route is composed of client 64 device 5, and that's it. And then we look at the query parameters later, and then also query. And let's assume that we've parsed this already. So we have new name is equal to computer. So we're going to find the plane subnode, or the subroute with client, and we just navigate there. Now, here we have 64, which if you look at the route definition, this goes to ID. So we put that in our dictionary. So now our dictionary, so route args, ID is equal to 64. And then we go down to a device, and then we go down to 5, which maps to device ID. And we add it to the list, or the dictionary. Device ID is equal to 5. And then we parse the query, which gives us this stuff here, and we parse that. Now, when we try and navigate, or when we're adding this to a list, we see, all right, I need 3 variables. I need 0, 1, 2, and they need to be in an order such that it's ID first, then device ID, then new name. So what we do is we scan route arguments and we put the ID in there, then we put the device ID in there, and then from the query dictionary we put computer in there. And we add them in order so that when we call dynamic invoke with the .to array, we're passing in the arguments in their order that we want them to. So we're just constructing them in order. And now we have looked at the route arguments. So now we're going to look at the query parameters. And this will look like else if. We're just going to look in the query parameters dictionary. So query params dot try get value. The string will be parameter.name again, and out string value string. And if this works, then we want to parse it. So we have it as a string now, but we haven't parsed it just yet. With try get value for the route arguments, we've already parsed it. That was up here. We have them as objects already. And then for query parameters, we're going to do is we're going to say if argtype dot try parse parameter, and we're going to pass in a type. Actually, this is the one thing I forgot to do. Argument type, we can't parse with just a type yet. The parameter has a type, param.parameter type, which is a type object, but we can't pass this into argument .try parse. So we're going to create a new function in argtype it's called try parse. So we're going to say, public static bool try parse. And we're going to pass in a type object and a string value and an out object value. And we're going to do a try and catch. This is going to look a lot like what we have up here with try parse passing in a template variable. So in the try, we're going to say value is equal to get argtype with type dot parser value string and then return true. So again, this will throw an exception. So if it does, this will probably throw an exception if we have the wrong parser, or if the parser doesn't exist. So then we will say value is equal to default and return false. And then in try parse passing in a template variable, we can simply just call. We can say value is equal to default, and then if try parse, passing in type of t, the template parameter, value string, and out object value, we are going to set the output value is equal to the t cast. So we're casting the object to that, and then return true, and then otherwise return false. So we're calling this new method that takes in a type object, and we're just setting the value. Now in route tree, we're going to use this new type parsing. And we're going to say if argtype.tryParse, and we're going to parse it as the parameter type with the value string and an out object value. And if this happens, we're going to say argslist.add object value. So we have sent it in as an object, and we're going to do continue. And otherwise, we're going to get to the null. So if this did not happen, if we weren't able to parse, then we're just going to skip all this and go to the argslist.add null. And let's try it. So let's go into program. Oop, I exited out. It's all good. Let's add the hello query endpoints here. So we will say rt.addRoute, and it takes in an integer and a string and then an integer. And so string integer, we'll say the method is just get, and it'll be hello/query, and the action will be action hello query. Oops. Does that exist? Yeah. All right. So we now have hello query, which is a new endpoint with the method get, and it takes in a string and an integer, and it wants to get these from the parameters. So string name and integer age from the parameters. So we will now do at the bottom, we will try and navigate. So try rt.tryNavigate, and we'll do a get method. So it's hello/query question mark name is equal to Michael, ampersand age is equal to 123. So I'll build. What do we get? All good. And then I will run. And it says, hello, Michael, with age 123. So it parsed everything properly, which is cool. Let's try switching this around. So let's say age is equal to 123 and name is equal to Michael. Still the same. It doesn't care about the order anymore because we just throw it into a dictionary. Let's try getting rid of a name. So we don't have an object. It says hello empty string. That's the default string value with age 123. And that's exactly what we want. If we're not passing in, we don't need to throw an error unless we say it's required, and we can do that validation at the controller. So we can just return an error if we wanted to, but this is just this is a much nicer way to do it, and we now have the flexibility to do age or whatever query parameters we pass, and we don't need to worry about the ordering. We don't need to worry about, oh, did this client did they pass in the arguments the query parameters correctly, because we can just associate it with the name. As soon as I found that delegate and looked at the little types and played around with it, it was like night and day, which is so cool. And another cool thing that we can do is, let's say we pass in a request body. If you don't know what that is, it's the same way you can return data. Here, I can actually look this up. HTTP request body example. So you might want to pass in something with, oh, that's a response, I believe. Here we go. Yeah, this is what I want. So this isn't an exact, I mean, actually, no, this is good. Yeah. So we have a post with a route, some host, whatever, content type specifies the type of the request body. And here we can pass in whatever we want. and it's going to be interpreted as a request body. So we can take this in as a JSON thing, which we will need a library for to make it if system.text doesn't work, which it may not. But you can take this in and you can pass it in just as a variable with its own name. And we won't even need the name. We won't really care at some point. But we will identify what the body parameter is. So let's go into the navigate function, and we're going to add a new parameter. So we have try navigate with method route, and now we're going to have a string body, which is equal to null by default. Here we are. And then before we navigate, so before we do this, we're going to have a Boolean just to say if we have a body. So Boolean body exists is equal to string dot is, or sorry, not string dot is null or empty body. And then we will say, sorry, this should be before the parameters. So this should be up here before we construct our list. So we will say in the beginning of each parameter, or in the beginning of the loop, because we want the body to take priority, we will say if body exists, and we need some other condition to ensure that the parameter is the body. And we could do types, but that wouldn't really work because you could have a million types. You can't just say parameter.type. What are you going to say this is equal to? The type of the body? Well, the body's a string, and it might be a million different JSON objects. So what we're going to have to do is we're going to have an attribute on the argument here. So if we're going to create another endpoint, so static void action body, and I'm going to take in a test class. So we're going to create something up here. Class test class. And I'm going to have a public string name, public int age, and public int grade, and public string home. So that's all there. Now in action body, we want to just take in a test class. Test. And we'll say console.write line hello test class.name, and I'll say in parentheses test class dot age, welcome to grade test class dot grade. I hope the journey from test class dot home wasn't too difficult. So it's just some string, and I want to print out all of the arguments. So it's just this long little body here. And we'll pass it in with into the add route method. So rt.add route, and it takes in a test class as the parameter type, and it's going to be, say, a put, and we'll just say slash greet, and we'll say action body. So we require no extra implementation or no extra logic in the add route method, because this is still just a delegate. It doesn't care. It only wants to know what's coming in the route. So we have our test class here. We have our endpoint set up. And now in route tree.navigate, we need to determine what's up with the parameter. So we need some sort of identifier, and C# comes in clutch again. Oh my God, they don't stop with it. Attributes. And specifically method parameter attributes. So these are attributes that you can just tag on, and I don't know what you can say. Attribute, something like that. You can have an attribute and it's going to be a class, but you can have it there, and then when we look at the parameter, we can get its attributes. So we're gonna, in route tree, we're gonna have a new class, and we actually don't need the get array anymore because we don't need that. So we're gonna say public class body. I think it's actually called from body in MVC, the web application that you can create with C#. So we're gonna have public class from body, and it's gonna inherit attribute. Oops, there. So we can now use from body as an attribute here. So from body, just like this. And this test class as a parameter now, in route tree, when we're iterating through our parameters, we can say if body exists and, let me find it, what the line is. And we want to find the parameters. So parameter.custom attributes .count is greater than 0. So we're going to just see if it actually has attributes. And then we're going to try and get it. So type parameter type is equal to null. And then for each variable attribute in parameter.custom attributes. And then if attribute dot attribute type, so this gets the type of the attribute, is equal to type of body. From body, sorry. Then we want to say parameter type is equal to param.parameter type. So what this logic means is, if the current parameter has the from body attribute, we want to find the corresponding parameter type, and we're just going to hit break. So we're going to exit out of this loop here, and then we're going to try and parse this. So we first want to make sure that the parameter type is actually not null. So we'll do a try catch block because we're going to parse this in two different ways. So try and then catch, but catch will be empty because if we can't parse it, then we're just going to fall back to the next one. And we will also do an else if there. So it's either body, route argument, or query parameter. Cannot be both. So we have a try and catch. In the try block, we're going to first try and parse it using an argument. So if argtype.tryParse parameter type, and the value will be body, and then we will output object value. And then we will say argslist.add object value. So we want to essentially parse it as something. It doesn't have to be JSON, it can be anything, but we want to parse it and see if we can parse it using argtype. And then continue. And then otherwise we're going to have to use JSON. And I'm going to try and see if JSON exists here. So using system, actually just JSON, no, system.text.json. Oh, okay. I forget actually how. Ooh, this is going to be fun. Do I remember what the JSON class is called? So we have text.json. I'm just going to look this up. C# JSON deserialize. All right. So we're going to say, oh, hold on. Okay. So it's going to be, sorry, where are we? We're here. So we're going to try and deserialize. So it's going to be JSON serializer dot deserialize deserialize, and the type will, or actually, can we pass in a type? Oh, I don't think we can, but not. We can actually specify a return type here, not in the template though. So we're going to pass in the string as the body, and the type will be parameter type. And deserialize returns an object, and it will throw an exception if something doesn't work. And that's where the cache comes into play, and in which case it would fall back to another case. So if we have an attribute, oh, actually, I may want to do something here. Hold on. So this should be continue. But if something breaks, oh, hold on. There may be some issues here, because if we have multiple custom attributes, which may not correspond necessarily to something that we care about, it's still going to enter this and it won't go into any of the other blocks. So we need to say if custom attributes dot count is greater than 0. And we're going to say continue, continue. But if an exception happens, we just want to go here. So we need to remove that else if and just make it an if. So what will happen is we will parse the body. So if body exists and the parameter has custom attributes, we're going to get the parameter type, and if that exists, and otherwise it's null. So if it's null, then try parse will throw an error. Or deserialize will throw an error. I can actually make this throw an error. This will throw an error, yes. Yeah, this will definitely throw an error. Will it? Oh, that's a good question. Hold on, try parse. This try catch. Oh, this will not throw an error. Okay. Do I need to say argtype.parse? No, it's only try parse. Here, let's do something here. We will only enter the try catch block if parameter type does not equal null. Then we will do this. So if we have found a parameter type, and the deserialize may throw an error, but we'll just catch it and move on. Because if we, actually, I want to do finally continue. Because if it's marked as a body attribute or body parameter, then I don't want to do anything else. I don't want to test it as a route argument. I don't want to test it as anything. I just control cannot leave the body of a final clause. All right, we need to go back to the empty catch block, and then just after that, just go continue. So if we get an error wherever here, we will catch it, not do anything with it, but then just continue afterwards. So whether or not we can parse it, as long as we find the attribute type, we're going to assume we want it as a body. All right. Very cool. Let's go ahead and test this out. So we have our action body here, and let's go and so we have it as greet, and let's try and do a console dot write line. We're going to try navigate to this is, what do we configure it as? A put slash hello slash greet, I believe. Or was it just, it was just greet. Okay. And then instead of passing in nobody, we actually have to pass in a JSON string here representing our object. So I'm going to write something. Actually, I suppose I can show you guys the string in a better format. So I'll do the @ sign so it can do whatever it wants. And for our test class, we need a name, age, grade, and home. So I'm going to do name. Oh, do I? Nope. All right, what's up with the syntax here? Backslash. Can I not use quotations? No, that's not it. That's also not it. I'm trying to use an escape character and I don't know if it's allowing me. Huh. You know what, let's do something a little cool here. Let's keep it as a null body for now. And we will create a test class. New test class, and we'll say name is equal to Michael, age is equal to 124, grade is equal to 123, and then home is equal to Antarctica. And then we will serialize this object using JSON. So I'm going to go up here and say using system.text.json. And then for the body, we will say JSON serializer.serialize. And I'm going to pass in a type, which is going to be, that's a good one. What is it? Test class. Let me just put this down below so you guys can see everything. So we're going to serialize test class using JSON. Actually, I don't even need that because it just determines it automatically. But we're going to serialize this to a string and pass it in as the body. And I will actually when we go try navigate and we find a body, I am going to print it out. So we'll just print it out over here. Console.writeLine found body, like so. So we'll be able to see the JSON input that we're taking in as the body. And we'll do a build. Please work. Succeeded. Control F5. Uh-oh. Oh, right. We didn't get a body. Let me console.writeLine, or let me just break and see what we get. Oh, the body, this deserial or the serialize didn't work. Do I need to add a thing? Let me try putting the test class there, even if it's redundant, just to see if that works. Shoot, hold on. Body is still null. Huh. Interesting. Oh, do I need to have the automatic? Oh yeah, I think I need to have the auto implemented properties. That's why. I think it might not work if it doesn't have them. Okay. Now let's build. Run. All right, so it got it everything properly, which is good, but parameter count mismatch. Okay. Do we actually send in the... This is a good question. Do we... you know why? Because we deserialize it, but we don't add it to the argument list. So args list dot add, and just add the deserialized objects. Okay, that makes much more sense. And then we should also just put an else here, because we don't want to add both. If we can parse it as both, we just want one. Build, Control F5. All good. Hello, Michael, 124, which is the age. Welcome to grade 123. I hope the journey from Antarctica wasn't too difficult. And yeah, so that is, yeah, we did it. That is named arguments, which is so much fun. Yeah. I suppose that I'm trying to deserial. I'm thinking of deserializing this, and trying not to have the body tag, because I'm just thinking like this could get clunky, and also, do we even want it? But the only way to identify, or I suppose what we could just say is, have an else block. So if we don't get it from route arguments or query parameters, let's just look in the body. Although, yeah, let's do that. I don't want to have a tag that's clunky. So we're going to have an else statement here. No attributes. We're going to say else look in the body. And I'm going to assume that you're not being an asshole, and you're not trying to get multiple JSON objects from your route, because why would you pass in JSON arguments in your route? That would not be... I suppose it could be query parameters, but we would catch it up here. And you would have to add it as a try parse. Do we want to give that ability to our users? Do we want to allow someone to say get hello question mark object is equal to some JSON? Do we want to do that? Why not? Let's do it. All right, so we first have to... So we have a parameter here, and we want to deserialize it as JSON. So we're going to do that before argument, or actually we can do it after argument, because if we have a custom way to do it, then we want to. Otherwise, we're going to do argslist.add. JSON serializer.deserialize value string as param.parameter type. So you can pass it in as a query parameter as well. And we will, I guess we have to do a try catch around this, don't we? This is great. A lot of code, but we'll do it. So we'll have a try catch here. I really wish you didn't need a catch, but I suppose it makes sense. So if this does not throw an error, then we are going to continue. And then just catch with an empty block there. So argslist.add JSON serialize.deserialize the value string as a parameter. And otherwise, we're going to look in the body. And it's going to be the exact same code, which I don't really like all that much. But I suppose we'll do it. Because there is... I suppose if we just... You know what? Let's do it this way. Let's assign value string out here. So we will say string value string and if query parameters.try get the value of the name, and we will output to value string. We'll say if not that, then value string is equal to a body. So if not in query, assign as body. And we're going to move this try catch block out right there. So we say so we get the value string either from the query, so look in query or body. So if it's not in the query, then we assign it to the body. And now we're going to just try and parse it as an object, as the specific parameter type that we want. And otherwise we're going to try and and if this succeeds, then we're going to continue. Otherwise, we're going to do a try and catch around deserializing the value from the argument list and continue, and args list.add null if nothing else, if that all fails. So does this work? And now that doesn't like this at all. Oh, because I was parsing the body up here, but we're now going to get rid of that because we don't have the attributes anymore. So I'm going to do a build. I'm going to actually get rid of the parameter class or the attribute class. Simplify things. Do a build. 1 succeeded, 0 failed, 0 up to date. Run. Still works perfectly. Bang. All right, I am done. Yeah, so that concludes our route tree. We have now built a full routing controller. You can take in any route and any specific route and map it to an action. I don't enjoy, where is it? I don't enjoy the templates here too much, but I'll deal with it. I will. Doesn't make too much of a difference. It's just annoying to have to do. But play around with this, please. And if you find any things that break it, please tell me. I'd love to fix it. But we now have the ability to pass in arguments from the route as an element, from the query, no matter the order, and then also from the body. And we can parse that with JSON or whatever we want. But it is super cool, and pretty soon we will be integrating this into a web server, and we can either create an API or something along that, and we will I'll play around with that. But yeah, I am going to be going home for a month now, so that will not come out for at least a month, probably early August if we ever do anything. But at home I will be programming a lot. I just won't be able to record anything. So there will still be stuff coming out though. I have a couple videos planned, but I will still keep that on the radar. All right, I hope you guys enjoyed. Hope you learned something too. I will see you guys in a month or so, live in a month, but I will be releasing stuff. Either way, enjoy yourselves and take care.